The last part of chapter 3.1 from your textbook describes different software vulnerabilities other than buffer overflow that we will discuss in detail in this video. Here's the laundry list of these other vulnerabilities. And the first one is incomplete mediation. This has a lot to do with access controls. So in our software, many times we forget to ask who should use this specific variable or who should be allowed to go there in this functionality, and this causes incomplete mediation. The opposite, of course, is complete mediation, where we have implemented in our software appropriate access controls. The next part in the laundry list is time to check, time of use. This has to do with timing type of attacks. So we maybe have a variable that we check it at some point and then we don't use it. So we check if our buffer is too large, but we don't use it until later, and at that later moment it may be tampered with. So this is a time to check, time to use type of flow. Then undocumented access controls, that again goes a little bit to access points, goes into points that you can access variables or memory, and checking for incomplete access controls. So good software has to have a policy for access controls. Then there's errors that have to do with what we call off by one. This is a more fancy way of discussing about range type of errors, like you thought that your range 0 to 5 included the number 5, but it does not. So these are these logical errors that could also cause issues with security. These are the off by one errors, these limiting case errors. We did not think of the zero case, or there are programming languages that do not have zero indices. I know that's really odd, but I've used programming languages like that. And then we have the next one in the list, the integer overflow, which can happen with languages like Java. It doesn't happen with Python because it has large integers, but it happens with the other languages. So the developer needs to know the limits in each language, the limits and the upper bounds for their numbers. Then unlimited null terminated strings. I cannot think of a case that you may encounter this in Python or Java. This was more usual in C, where you would have strings that were not being terminated with the proper end of string type of character, a special character. So these types of errors, parameter length type and number are when you have too many parameters and you don't check, or you have wrong types of parameters. And then, of course, unsafe utility programs, unsafe libraries like string copy versus strn copy. And then race conditions, these are very hard to find. They could have to do with your multi-threading, where a procedure is being executed and the outcome affects another procedure, and there may be an infinite loop, a race condition, where inconsistent outcomes may happen and affect the integrity. This last one in the list is very difficult to find. But being aware of these programming flows, as you can see, makes you a really much better software developer. These are very avoidable, most of them except maybe the last one that could be very difficult to check. But all the rest of them are very avoidable if there are proper policies and adequate time to test the software, which all companies now are trying to do more and more.